Hello, Tigers. Today we're going to be working with a system of linear inequalities. And you remember back in our last target, we talked about a system of equations. Well, same thing is true for a system of linear inequalities. We're going to be talking about more than one linear inequality. Just like with a system of equations, we're talking about more than one linear equation. Same thing. I can graph a system of linear inequalities on a coordinate plane, and I can check points in the intersection of the solution area to verify that they represent a solution to the system. And of course, we're going to be working with that today. System of linear inequalities, two or more linear inequalities together form this. So today we're just going to be working with two, but note that it could be more than two linear inequalities. A solution of a system of linear inequalities makes each inequality in the system true. The graph of a system shows all of its solution. I would suggest as we're working through the problems today to use two different colors, like two different colored pencils or two different highlighters, so that you're going to be looking at the solution to both inequalities and then seeing where that overlap is. This is just a visual. This is going to be in your book on page 411 if you want to look at that. X is less than 0. We're just talking about this. And then Y is greater than 0. We're just talking about this is determined in that particular quadrant. So it just breaks it up into quadrants. If you'd like to take a look at that on page 411, you may. Is the given ordered pair a solution of the system of inequalities? So if you want to know if it is a solution to the system of inequalities, then you're just going to look at the ordered pair and you're going to substitute that in to see if it is a true statement using X and Y. So this says equations, but it could also be the word inequalities. Same thing here. In order for the ordered pair to be a solution, it has to satisfy both equations. Well, we could also say both inequalities. So you know that back from using a system of equations. Same idea. Solve each system of inequalities by graphing. And you can graph however you feel fit. You can graph using slope-intercept. You can graph in standard form if that is appropriate. So y is less than negative x plus 3. Y is less than negative x plus 3. That's already in slope-intercept form. I need my y-intercept, which is 3. I need my slope, which is going to be a negative 1. So I'm going to come over here and graph it. The slope is down 1 over 1 and repeat that process. So once I know the points in the graph, then I have to determine what kind of line. So in this case, it's a less than. So if you remember from section 7.5, if it's less than or greater than, then it's going to be a broken line. And if it's equal to, like less than or equal to or greater than or equal to, it's going to be a solid line. So that is important to remember in this lesson as well. So it's going to be a broken line. Make sure you're using your straight edge for me, please. And then you just want to make sure that you have arrows at the end of both particular lines. As far as the order you do this in, I would highly encourage you to graph the line. And now we're going to determine which side of the line to shade on. So you're going to basically do the same thing you did in section 7.5. You're just going to do that 2 different times. So graph the line, and then we're going to determine which side of the line to shade on. If you remember, we're going to use a test point. 0, 0 is always a good test point if it's not on the line. So our origin is 0, 0. I'm going to use that and go back in and substitute. So I've got 0 is less than 0 plus 3. 0 is less than 3. Well, that's a true statement. So if it's a true statement, I always want to shade where it's true. So that means I'm going to use a highlighter. Fancy on you today. So we're going to shade here below the line. Make sure you're using a test point to do that. Don't just guess which side of the line you're supposed to shade on. Okay, so that's our first linear inequality. And now we're going to look at our second linear inequality. So I've got negative 2x plus 4y is greater than or equal to 0. And that would be all fine and good, and I could use that in standard form. The problem is that it's equal to 0. So I know that it's going to go through the origin because I'm going to need a 0 and a 0 to make a 0. The problem is I don't know the slope. So the way to get there is to put it in slope-intercept form. Okay, so to do that, I'm going to add 2x to both sides of the inequality. So I've got 4y is greater than or equal to 2x. Divide through by the coefficient. Y is greater than or equal to 1/2 x. Remember, if this is a negative, then you would have to flip the sign, but it's positive. So we're just going to leave it as y is greater than or equal to 1/2 x. So I need the slope and I need the y-intercept. Well, there is no plus b term, so that's 0. We already kind of anticipated it going through the origin to begin with, and m is equal to 1/2. So from there, we're going to go up 1 and over 2 and repeat that process. Or down 1 and back 2. From here, I have to determine what kind of a line, and it's greater than or equal to, so that would be a solid line, meaning that the line is part of the solution. These tools can be a little tricky. Sometimes I need to go up a little bit more because I know I definitely want to make sure that it goes through the origin. That's going to be really important, especially for this problem, because we know that if it goes through the origin, then I can't use that as a test point. So I want to make sure you can see that it goes through. Probably as good as it's going to get. So we know that it goes through the origin. We have to use a different point. So I'm just going to kind of stay close to the origin, and I can choose any point. I just want to know which part I'm supposed to shade on. So I'm just going to stay close, and I'm going to use this point here, this -1, 1. And remember, if it's true, I shade on that side. If it's false, I shade on the other side. So that's what we're trying to determine. If I substitute in -1, so I've got -2x plus 4y, going back to our original statement, and I'm going to substitute in -1 for x and 1 for y. So -2, just do the math here, plus 4 is greater than or equal to 0. Well, 2 plus 4 is 6, and 6 is greater than or equal to 0. That is a true statement. So my test point was at -1, 1. So I want to make sure that I shade at -1, 1. So I'm going to choose a different highlighter, and I'm going to shade then above the line, the solid line I just drew in. Now, we already know that -1, 1 satisfies the second inequality because that's the point I used to test it. But it also, -1, 1, should also satisfy the first. So if I say 1 is less than negative, negative would make a positive, 1 plus 3, that does in fact check. So 1 is less than 4. The point is that what you're looking at, and I know it kind of looks like a mess, it's a lot of shaded area, but what we're looking at then is this area in between these two lines. So everything all the way, keeps going forever and ever in this region, that is a solution to this problem. So you don't have to do what I just did and emphasize that area. We can see wherever you have shaded in that overlap, that is going to be the solution to this inequality. Moving on to our second example. We just have to graph. So we have to determine, am I going to put it in slope-intercept, or is it appropriate just to use standard form? And I like this because 6 and 4 go into 12, so I can just use what I call a mini table of values where I use 0 for x and 0 for y. So when I substitute in 0 for x, then that would mean 4 times 3. That's going to give me 0, 3 would be my y-intercept, and then to substitute in. If 0 is y, then 6 was going to have to be 2. Okay, so 0, 3, 0 over, 3 up. Make sure you graph this correctly, and then 2, 0. And then we have to determine if it's a solid line or if it's a broken line. Well, it's going to be a broken line because it is greater than. And I'm going to have to add my arrows. They're going to look kind of funky. And then I need to do the same thing. Oh, I want to go ahead and then shade. We want to determine, just use your test point. So I know I'm going to use 0, 0 because the line does not go through 0, 0, so that's appropriate. And when I substitute in, then I've got 6 times 0 plus 4 times 0 is greater than 12. Well, that's just going to be 0. 0 is greater than 12 is a false statement. So I don't want to shade where the origin is. I want to shade on the other side. Since it's false, then I don't shade where 0, 0 is. If it's a true statement, I would shade at 0, 0. Please make sure you're making a good decision about which side of the line you're shading on. You want to shade where it's true. Okay, that looks good. And then, with the exception of this little overlap here, clean my mess up. That's not going to let me, but you get the point. And then now I need to do the same thing for the second inequality. So negative 3x plus 4y is greater than 12. I'm going to use, once again, I can use my little table of values because negative 3 and 4 go into 12. So this makes this 0 plus 4. I need a 3 here to make that statement true. When I substitute in 0 for y, then I would need a negative 4 to make that a true statement. Now I'm going to graph. So 0, 3, looks like they share the same point here. 0, 3, and then negative 4, 1, 2, 3, 4, 0. I have to determine solid or broken based on the inequality sign. That would be a broken line. Try that one again. Yeah, third time's a charm, right? 4 and more. That's going to have to cut it. Arrows at either end. Then determine which side of the line to shade on. So I can use 0, 0. That's a good one to use. 0 plus 0 is greater than 12. Is that a true statement? 0 is greater than 12. No, of course, that is a false statement. So I don't want to use the origin. I don't want to shade there. I want to shade above the line. And then we want to see where the overlap is. So the overlap, of course, is going to be between, oops, can't see that. Let's try this. Between this line and that line. So we're talking about up here. That is the solution. So if you would to randomly choose a point in that section, then it would satisfy not one, but both of the inequalities. I hope you enjoyed your lesson on solving a system of linear equalities today.